Nyam. Nyam.
Again. Kami muna. Sige lang.
Okay, class. Today in math, we are going to discuss how the mathematical functions we discussed are present in other fields of study. Now, do you guys know what an SUV is, or a sports utility vehicle? Okay, those are the bigger cars that are for family cars. Okay, in comparison with the smaller and standard cars, if you notice, the miles per gallon is a lot lower than the standard car. Do any of you know why this is?
Is it because of the mass or the size of the car?
Yes, exactly. It's related to the mass. This is because to accelerate them both at the same pace, greater force has to be exerted on a body with a greater mass. Now, this is exemplified in Newton's second law, which is what we call the law of acceleration. Mathematically, it is expressed as F equals ma. Now, if you're going to notice, this is very similar. The form of this is very similar to a function that we've already discussed. Can anybody tell me what type of function this is? Yes.
Linear function.
Okay, very good. It's a linear function with the form y equals mx plus b. Now, this is a linear function, even though the variables are a bit different. There we have an a, because assuming a given value for m, for example, the mass is 1,500, which is the average mass of a car. Assuming that the value of m is 1,500 and then we have an a, the 1,500 here is what we call as the slope. You guys already know what the slope is. And we have the acceleration and the force exerted. Now, in the function f equals ma, the mass should always be greater than 0 or equal to 0. But if m is equal to 0, then we are not measuring anything because the mass is 0. But it should also always be greater than 0 because the mass in physics can be negative. Meanwhile, the acceleration, the parameters for acceleration is any real number. It's an element of any real number because the acceleration can be negative, it can be 0, and it can be positive. But when it is 0, the function then will become a linear function. It will become a constant function. Sorry, because f then will always be equal to 0 no matter what you substitute. Okay. Okay. We have in this formula both an independent variable and a dependent variable. Now, the independent variable is basically what we are controlling, what we are inserting values for, while the dependent value is what we are trying to measure. Okay? So in this formula, keep in mind that the independent variable is a, the acceleration, while the dependent variable is force, f. Now, on our outline here, we've completed A to C. Make sure, class, that you're taking notes. This will appear in your finals next week. Now, the domain and range of the function f equals ma. As we've already said, f equals ma is a linear function. So judging from that of what we have previous knowledge of about linear functions, the domain and range of f equals ma is all real numbers, which is expressed as negative infinity and positive infinity. Now, segue a bit. Force is what? Is it a vector quantity or a scalar quantity?
Scalar.
No. What we mean is that force is a vector quantity because it can have direction. Now, since it can have direction, it can be exerted in the opposite direction, which means it can be negative. So, if we have a negative f in the function f equals ma, but we've already said that m should be greater than or equal to 0, then to achieve a negative f, the only variable here can be negative is a, right? So we can have a negative a since a can be any real number. But what a negative a means is that the acceleration is not actually acceleration, but deceleration. It's slowing down instead of increasing its pace. Alright? Now we're going to move on how we're going to derive the inverse of this function. So what we've already taught you is basically, to get the inverse of the function, you switch the places of x and y, and then find y. So since our x is a and our y is f, we're going to switch up the roles. We have here a is equal to fm. Now we're going to find f. F is basically divide both sides by m. F then is equal to inverse, equal to a over m. Okay, so now we're going to graph the graph of f equals ma and its inverse, f is equal to a over m. Now, I've already graphed and screenshot a picture of the graphs beforehand. So, if you'll only take a look at the graph there, you will notice that this red line is the graph of the first function f equals ma, and this blue line is the graph of its inverse f equals a over m. Now, it might look like it is aligned with both the y and x axes, but these are actually increasing graphs. It only looks like this because the value we assigned for m, which is 1,500, is very high, which makes it very steep. Okay? So, if you're also going to notice, we have a point of intersection here at the point 0, 0, which is the origin. Now, why does this make sense that the point of intersection is at the origin? Okay? If we recall correctly, x is represented by a acceleration. X as x. And the y here is the force. Now, if their point of intersection is 0, 0, then both of those values of acceleration and force are 0. Now, this makes sense because if the acceleration is equal to 0, then obviously the body is not moving, which means consequently that no force is acting on it, 0. Now let's look at it backwards. If the force acting on an object is 0, then it is not moving, which means it is not accelerating, which makes sense that the value of a is 0. Okay? So now we're going to cover the zeros of this function, f equals ma. Now, the zeros, if you recall correctly, is the value of x that makes the function equal to 0. Okay, so f equals ma, right? Now, how will this function be equal to 0? We substitute again a value for m. We assume that the value of m is 1,500. A is equal to 0. Now, to find a, we divide both sides by 1,500. And then we get that a is equal to 0. So a value of acceleration will make the function equal to 0. Now, since this is a linear function class, do not be looking for any asymptotes because a linear function by nature does not have any asymptotes. So in our discussion of functions, we will also discuss inequalities. So why not make this discussion a bit more fun? Let's try making it an inequality and interpret what this means. Okay? So instead of being f equals ma and substituting a value for m, let's try interpreting f is greater than the value for m, 1,500, then a. Now I've made a graph for this also, and it looks like this. So basically, if we're going to interpret this, what this means is that the force acting on an object in physics should always be greater than the product of the object's mass and the rate at which it increases its velocity, its acceleration. Okay? Now, let's level it up a bit. Okay? We've also discuss compositions of functions. Okay, so let's try doing that in this function. There is another formula for acceleration, and it is expressed as acceleration is equal to delta v per time, or acceleration is equal to the final velocity minus the initial velocity over the time. Okay, this function for acceleration can be used in the original function that we have, which is f equals fa. So we can perform the composition of the function f and a, expressed as follows. Okay, so what will happen if we do that is that the function a will be substituted in the x of our original function, in this case, the a. Okay, so that will be illustrated as like so. Okay, how can this be used in real life? Because we are always grounding our discussions in real life, right? Now, this can be used when the acceleration is unknown, but the mass is known. Okay, I've made an example earlier of miles per gallons in cars, right? So, to know if your gas consumption is increasing, you should always know the force that you're exerting on it. But there are times when you know the mass of your car, but you don't know the acceleration of your car. Okay? So, since the velocity of your car is very easy, and the time you've been traveling is very easy to find out, you can easily find out the time of your travel, and the velocity is seen from the speedometer in your car, you can use this composition of functions to identify the force that you're exerting on the car, and to know if your gas consumption is increasing. Okay, that is the end of our discussion for today, class. We've successfully discussed the function s equals ma. Now, I'm very sorry, but due to the recent suspension of classes because of the typhoons, the earthquake, I will have to assign you different types of functions on which you will be also relating to the field of study physics. Specifically, I want you to study amongst yourselves 3 kinds of functions. First, I want you to give me a rational function, a trigonometric function, and finally, a quadratic function. I want you to discuss what I have discussed, which is first the context of the function you're going to be assigned with, or what you're going to think of. Why is it that specific type of function? Explain to me why it is a rational function, why is it a trigonometric or a quadratic function. Then identify both the independent and the dependent variables as well as the parameters. Which of the values should be greater than or equal to 0, or can they be any real number, or can they be not equal to a certain numeral? Okay? Also, I want you to show me both the domain and the range of the function you're going to be discussing. And derive what is the inverse of the function. You already know how to derive the inverse of the function, so that this should be very easy to you. Then, show me the graph of both your original function and then your inverse function that you've derived. You should properly be able to describe it. Tell me, what are the intervals on which they are decreasing and the interval on which they are increasing. And show me the zeros and the asymptotes if there are any. Such as for a rational function, there should be asymptotes here. I'm going to be expecting an asymptote on a rational function. And then, give me an explanation on what it would be like if the function would be an inequality. And explain it to me. And finally, you should be performing a combination with another function. That is, think of another function that could go well with the function you're discussing, and then apply a type of combination to it, which is addition, subtraction, multiplication, division, or composition, and then explain to me what is the result. Okay? That's all.
Uy, guys, I have a bright idea. Mag-group study na lang tayo.
Uy, game. Gusto ko yan.
Pero paano yung mga formula pala?
Amin na lang
Try ko na lang sa amin.
Tapos kami ni Nat na lang sa quadratic.
Sige.
Kaso, ano maganda? Rational na lang? Ako na lang mag-isa?
Kung
Kaya
kaya mo, magaling ka naman, gagrama ka pa eh.
Talino ka naman. Pero saan tayo mag-aral bukas?
Siguro sa amin na lang bukas. Sige na.
Yun, yan, gusto kaya may pagkain, may
Sige,
pagkain.
sige, bukas.
Kita-kita lang tayo.
Yes,
ah.
sige, sige, sige.
The next day. A few moments later.
So, start na pala. Yung nakita namin kasing formula ni Aral na quadratic sa classical mechanics is for the formula of displacement, which is this one. Yung VI stands for initial velocity, T stands for time, and A stands for acceleration. Yung initial velocity mo, initial velocity and acceleration can be any real number since vector quantity siya. Pero yung time mo, positive, obviously, positive real numbers lang. Ayan. So, bakit siya naging quadratic? Dahil, if you can recall, yung standard form ng quadratic function is ito. Ayan. So, at first glance, hindi siya mukhang pareho, di ba? So, pero pag commutative property na, using the commutative property of addition, pwede mo siyang gawin ganito. So, yan na. Wala siyang C dahil, pero yung C kasi pwede mong maging value doon is 0. Yan. So, yung 1/2 A mo dito, yun yung A sa standard form. Tapos yung initial velocity, yun yung B. Okay. Yung D dito, yun yung dependent variable. Tapos yung independent variable man can either be A or T or the initial velocity. So, ang pinili namin in this case is going T yung independent variable para hindi tayo magulahan. Ayan. Tapos yung inassign namin values for A is 2 meters per second squared. And for the initial velocity, yung inassign namin is 10 meters per second. Yan. So, kunin na natin yung inverse. Diba? Sabi ni sir, kunin yung inverse, diba?
Oo, sabi naman yun.
Okay. So, D was 1/2 tapos T squared plus 10 T. So, yung first step ng pagkuha ng inverse is to pagpapalitin yung y and x, yung y independent, di ba? So, magiging t equals 1/2 2 tapos d squared plus 10d. Ayan. So, ang pwede mo na lang gawin is simplify ito. Ayan. So, magiging t equals d squared plus 10d. Ayan lang. Sulat ulit natin dito para hindi magalo. So, ang option natin dito is i-complete yung square. So, para magawa yun, i-divide mo yung b, value ng b to 2. So, 10 divided by 2 equals 5. Tapos, i-square mo yan. Equals 25. So, yun yung value na i-add natin to both sides. So, t plus 25 equals d squared plus 10d plus 10d plus 25. So, ito, pwede na natin i-condense to. So, t plus 25 equals d plus 5 squared. Ayan. So, para ang goal naman natin dito, di ba, from in the first place is to isolate d. So, para ganyan, i-squared muna natin to. Squared. Both sides. Magiging d plus 5 equals square root of t plus 25. Ayan. Tapos, yan, para ma-fully isolate na d, i-transpose natin to. Magiging d equals square root of t plus 25 minus 5. Ayan. So, yung para sa graphing, makita natin yun sa ginawa na ni Eray sa Desmos. Okay.
Ang galing.
I-ano mo na pala, explain mo na sa kanila yung graph ng sa atin, tapos order mo ng food. Sige na, sige.
So guys, habang nag-explain si Nat kanina, niready ko na yung graph ng quadratic function. So, ito yung mukha niya. It's a parabola that opens upwards and yung vertex niya nasa negative 5 and negative 25. Tapos yung x-intercepts is r since quadratic function at 0, 0 and at negative 10, 0. While yung y-intercept is at 0, 0 din, same nung sa isang x-intercept. So, yung zeros niya, diba, same lang naman siya sa x-intercept. So, ang zeros are 0 and negative 10. Tapos, since quadratic function, walang asymptotes, nag-extend lang siya to both sides of the, sa buong, graph. Tapos, kung, diba, ito yung graph ng kasama yung inverse ng function, ng quadratic function, which is, bakit, diba, kalahati lang to? Kalahati siya kasi diba pag inverse, dapat positive root function siya. So, yung taas lang yung kinukuha, kahit dalawa yung nakuha ni Nat kanina. So, yun. Kung gagawin namang inequality yung quadratic function na to, magiging, kapag less than, magiging ganito siya, yung solution nasa labas. Ibig sabihin nun, yung displacement, less than siya ng sum ng initial velocity times time, tsaka yung 1/2 ng acceleration times time squared. Tapos, kung i-combine naman natin yung function na to sa iba pang function, ang lalabas dito is, yan. Yung pwede natin gamitin, yung formula ng work, which is fd times cosine theta, which is f yung force, d yung displacement na pinakita namin kanina, and theta is the angle of inclination. So, ganito yung pwedeng pag inayos, pwede maging ganyan. Tapos, ang tawag sa combination na to is composition.
A few moments later.
Okay.
So, guys, yung trigonometric function namin is work equals force times distance times cosine theta, which is sabi na ni Eryka kanina. So, this function is under Newtonian mechanics. Formula siya for work. Work is force exerted times distance times the degree of inclination. So guys, trigonometric function siya basically kasi merong cosine. Cosine is one of the most common trigonometric ratios. Ano yung sine, cosine, tangent? So yeah guys, yung independent variable dito ay yung force or distance. Tapos yung dependent variable naman ay yung work. Force, so yung kaya siya dependent variable kasi yun naman yung pinakompute natin. Tapos kaya naman siya independent kasi yun yung minamanipulate, di ba? So, force, it can be any real number, negative or positive. Meanwhile, distance, it has to be greater than 0 or it has to be greater
Yung distance of
distance is greater than or equal to 0. Kaya yun.
sunod naman natin sa gagawin is kunin natin yung inverse nito. So, para makuha natin yung inverse nito, una, pagpapalitin natin yung theta at W. So, magiging ganito siya. Next is to divide both sides by FD. So, magiging theta over FD is equal to cosine W. Tapos kukunin natin yung inverse ng cosine. Ang tawag doon is arc cosine, actually. So, magiging ganito siya. W is equal to cosine negative 1 theta over FD. Ngayon, so ito yung graph nung kanina, yung W is equal to FD cosine theta. Tapos, ang makikita naman natin na yung domain niya is all reals. Tapos, since ginawa natin yung D na 5 meters, yung F niya is, yung range niya is from positive 5 sa taas, tapos negative 5 sa baba. Tapos makikita natin na wave siya, pag ganun siya. Tapos kung mapapansin natin, marami siyang zeros. May pattern yung mga zeros niya. Pwede nating sabihin na yung zeros niya ay 2n minus 1 pi over 2. Kasi kahit yung n mo doon, kahit anong number. Halimbawa, yung n mo is 1. So 2 times 1 minus 1 over 2. So 1/2 pi, which is dito yun. Okay. So, ayun. Tapos na tayo dun sa zeros. Tapos, papakita ko naman sa inyo yung graph ng inequality. Ay, mali. Yan. Bakit? Ako lang din ang magkakamali. So, yan yung graph ng inequality. So, makikita natin, ito yung F equals FD cosine theta. So, lahat nung nandun, ibig sabihin, mas malakas na work. So, in context, masasabi natin na kapag mas malakas yung work mo kaysa dun sa required na ma-push yung isang bagay to an inclined plane, mas mabilis mong matatapos yung gawain na yun. Well, pag less than naman siya, kasi ito greater than to eh. So pag less than, yung baba naman yung naka-shade. Ibig sabihin, it's either hindi mo matatapos yung work na kailangan mong gawin sa inclined plane or mabagal mo siya matatapos. So, yung sunod naman is, di ba sabi ni Sir, kailangan daw natin may pagsamahin daw na dalawang equation. So, ang ginawa namin, sinama ko yung isang sa force, which is MA. Bakit? Kasi yung una sa inclined plane. So, kunyari, nagpupush ka ng isang, kunyari, piano. Dadalhin mo sa isang truck, ganun. So, ipupush mo yung piano dun sa rampa. Ito yung equation na yun. Tapos yung force na gagamitin mo para mag-push siya dun, papasok ng truck, yung MA. Nagets nyo ba? So, yun lang naman yung amin, no? Okay. Ox na yun.
Basta sino nag-isi next?
Oh, syempre yung lane.
Syempre.
Dumating na nga pala si Dovie, nakalimutan ko. Mega man, ito na.
Ito na.
Save the best na ko lang hinap.
Yes. Ang tagal na natin.
Yes, gutom na ako.
Oo. Uy!
Yun na ba yun?
Oh, yes.
Ayun, yes.
Oh, may pagkain.
Yun.
Tapos nagdala ka pa ng Uy, Jollibee!
Yun. Bidang saya talaga.
pala.
Oo, grabe naman.
Hindi na naman
Sinimakain na natin si
Kanina.
Ay, wait, tapos na ba i-explain nila Macrine kanila?
Oo.
Sige, aralin.
Turo na lang kay Dovie. Talino ka naman eh.
So, aralin na lang natin yung kay Dovie.
Oo.
Sige, kain na lang muna tayo habang nag-explain siya.
Mega may 2.0.
Uy, dahil dito ka.
Ready ka na ba? Wait lang.
Bilis, kain tayo.
Kain muna tayo.
Okay, ito na. Guys, dito na. Not dito ka na, para matapos na tayo.
Sige. Ay, matapos lang. Wala tayo.
Pwede mo. ito na. Ito yung rational function, di ba? Kinuha ko is velocity, pero since alam na natin lahat yung formula for velocity, ginawa ko na lang siya ng time, dinerive ko. Dito yung time, yun yung kung gaano katagal nag-travel yung object, tapos yung v, distance, kung gaano kahaba yung travel ng object, tapos yung v, yun yung speed of force. Tapos alam niyo ba kung ano yung difference ng velocity ng speed? May direction motion. Ayun, tama. Pag velocity, may distance, so vector quantity siya. Kapag speed, ano lang siya, yung value lang is. Okay. Sige. So, tapos, yung, alam niyo ba yung standard form ng rational? Di ba ito yung standard form natin?
Ayun, yun.
Yan. P of x equal over, all over Q of x. So, dun sa formula ng time, yung P of x yung distance, tapos yung Q of x yung speed.
Nalala ko na.
Tapos ang independent variable dito, yung speed. Tapos, di ba? Tapos yung time, yun yung dependent since nagre-rely siya sa magiging value ng speed. So, ang magiging value ng v is any real number except for 0. Sa time naman,
Wait, bakit is that 0? Bakit is that 0?
kasi pag ginawa mo siyang 0, magiging undefined yung equation.
Okay.
Ayun. Yun lang naman yung domain range niya. Tapos, pag ginawa mo siyang inverse, ito yung nakakatawa dito. Pag in-inverse mo siya, di ba magiging v equals d over t. Kasi yung y natin is yung t. So, magiging y natin yung v. Tapos x yung v. Diba? Tapos kapag, so times mo both sides by t, magiging ganito siya. Tapos i-divide mo both sides by v. Tapos ganun pa rin yung pinilabas. Wow!
Bakit sila?
Ganun
yung pag dinarive mo try mo mamaya.
Sige.
So sa graph, ito yung magiging itsura niya. Assuming na yung distance natin, 180 kilometers na travel ng object, ito yung magiging graph niya. Paano kabila? Hindi siya pwedeng maging, in real life, hindi siya pwedeng maging less than 0. Kasi, wala namang negative na time. Tsaka speed. Tapos, yung nakita ba yung graph niya, may asymptote siya. So, approaching 0 siya. As the velocity, or I mean speed increases, yung value ng time nag-decrease siya. So, approaching 0. Hindi ganun din dito sa may y-axis. Tapos since ganyan yung graph niya, wala siyang zeros. Hindi siya mag-intersect sa kahit anong axis. Diba? And yung kapag tapos tinry ko siya mag-inequality, ganito yung itsura niya. If time is less than or equal to distance over velocity, ganito yung itsura ng graph niya. So, ibig sabihin nun, yung value ng time, lagi siyang magiging less than sa value ng pag divide mo yung distance over the speed. Ganun yun.
Wala yung intersects, di ba?
Oo. Ano ba?
Saan na ito-combine yung function?
Ayun, oo nga. So, naisip ko, since speed yung pinag-uusapan natin, naisip ko yung, wala na ko na naisip ko. Ito na. Yan. Kasi, ito yung 2πr. Itong formula to is for circular velocity. Kapag yung travel parang pabilog, circular motion, ito yung magiging, ito yung parang circumference nung tinatravel ng object pabilog.
Tinuro niya ni Sir.
Tapos, kung titingnan nyo, yung 2π, ito yung magiging distance kasi ito ay circumference. Pero dapat hanapin mo muna yung radius ng circle na yun. Saka mo i-divide over velocity. Yun yung circular velocity kapag travel siya in circular motion. Tapos yung combination niya, di ba I mean yung type 2. Composition. Kasi nga, nilagay yung siya. Parang yung distance, pinalitan mo ng 2πr. So, that's yun ang pakala yung rational. Yes.
Ready na ba tayo sa
Ready na ba tayo sa
test natin?
Oo.
Sana.
Sana kaya natin yung basic na
Study na tayo.
group study pa tayo.
Oo nga.
The next day.
Kailangan pa natin ng calculus.
Hindi naman yata.
Mag-graph ka ba?
Para naman kayo eh. Basic na yan.
Megamite ka.
Megamite. Ito, lalo na kung megamite. no?
Okay, class. Good morning. We are scheduled to be having a test today. So please keep any and all notes on your desk or on your person. Any notes I may find, be it related to the test or not, it is still considered as cheating. Also, your phones obviously are not allowed to be used at this time. And since you're only be going to discuss concepts of the pop-up functions, calculators are not allowed. Now, the test is only good for 30 minutes and it has two sets, set A and set B. Okay, so without further ado, let's administer the test. Okay, please write your name, section, and ID number on the top part of the page. Once you are done with the test, you even before 30 minutes, you may approach me at my desk and then give me your paper and then you may leave. Best of luck.
A few moments later.
Pasa na ako.
Okay, pasa na rin ako. Tapos naman.
Thank you, sir. Bye-bye. Bye, sir. Uy, so, kumusta natin yung test?
Kasi madali lang. Basic.
Oo, dahil sa graduate.
Bigla, ang sagot mo sa 2.
Ay, hindi ko perfect.
Siya tayo.
Ay, grabe, thank you naman. Perfect ka ba?
So, tama na yun guys. Lunch na tayo.
Tara, tara. Libre na. Perfect. Perfect.
Hindi, perfect mo doon.
Oo.
Oo, nga, bakit libre mo kami kapag perfect ka?
Oo nga.
Sige, sige.
Uy, wala pa naman.
Hello po sa memory card ni Dovie. Memory card, sige.
Ginawa mo yung perfect ko?
Ha? Wala. I-tapusin mo na yung record.
Wait lang, ulitin
Ano
mo.
yung value ng times?
C